Okay, welcome back, Science 8. We are continuing the water quality lesson, part 2 of Unit E, which is last unit, fresh and saltwater system. Let's do a little bit of recap. Last time we learned that saltwater system, which is saline water, ocean water if you will, the one that is most abundant on Earth if you will, takes about 97%. Mathematically, which leave us that fresh water is about 3% of overall body of water that is available on Earth. And if you think about various forms of fresh water, we have a lot in terms of lake, river, creek, flowing water versus something that is more trapped or stationary like glacier and ice cap. We also learn about how pollutants due to industrial process, if you will, industrialization that happened since 1800s to all the way to this modern era, we increased a lot of greenhouse gas that speed up the process of global warming, something like carbon dioxide, nitrogen monoxide, plus we use various chemicals that make ozone layer thin. And if the ozone layer gets thinner, we will have more UV radiation. And as I mentioned, greenhouse gas, we speed up the global warming. And that increase in overall temperature, both of them play at the same time simultaneously. And that causes, how can I say, less availability for the fresh water when it comes to human. We're gonna go and connect it from where we left off. Last time I mentioned that seawater contains several salt, and according to chemist definition, salt is not talking about table salt. In fact, salt refer any type of ionic compound, ions if you will, specifically. And some ions, yes, it give you saltiness, like sodium and chloride. But if you have an experience of drinking seawater accidentally, you will notice that it's quite bitter. And that's due to magnesium and others that you see. Thus, most of the dissolved substances, which is invisible to us obviously, atomic level or microscopic level of ions specifically, we call it salt. As I mentioned, salt is not equal to what I like to call table salt because table salt is specifically referring sodium chloride, and the thing about sodium chloride is, and it's work for any type of other ionic compounds too, if they have a metal like sodium and non-metal like chloride, they tend to dissolve in a water in the form of ion. They separate as positive ion and negative ion. This is a reason why if you read or if you watch a lot of documentary videos, some of the science facts, if you will, seawater is a very good conductor because it has lots of ion that has charges, so you can make electricity go through. So there are levels, or how can I say, define the level of water depends on what kind of salt are dissolved. When it comes to pure fresh water, if you will, and last time I mentioned, there's something called ppm, parts per million. ppt is parts per trillion, which is a fancy way of saying you have certain amount of small solutes in a very, very, very large volume of solution. So fresh water, almost close to zero. Almost close to zero salinity. Salinity is the level of bunch of ions including sodium and chloride and anything else, magnesium and so on. All of them are dissolved. It's a concentration, if you will. Concentration for iron. If we have about 20 to 31, so we have certain level of concentration, we call it brackish water. Then, if it's another level, which is, I call it maximum level because we didn't find any of a natural solution that has more dissolved salt and ions than seawater, ocean water, we call that maximum part marine. So in that perspective, seawater that has high concentration of ions and salt, including sodium chloride, that have a level of marine, if you will, we're gonna call that percentage bar, if you will, about 3.5% concentration. And when I say 3.5, how can I put it in an easy word? Think about it in this way. If you have 3.5 liter of salt and ions inside of 100 liter of total volume, which means if you think about the actual water content, it will be about 100 minus 3.5, which is 96.5 liter of water and 3.5 liter of actual salt and ion. I think yesterday, one of my students was saying, when I was talking about what kind of stuffs are dissolved in water, jokingly someone said gold. Well, not a major content, but I don't want to say it's really wrong. There are minor percentage, well, it's 0.0 something percentage, so it's kind of hard to say as a percentage. There are very, very minor amount of metals inside there too. So some of them are, gold, silver, lead, mercury. Those kind of heavy metals are also dissolve in water. Not in a solid format though. Certain tiny amount of ions. But I want you to put this one though. If you think about Fort McMurray, where there are a lot of oil field exist, if you will. If you have a lot of industrialization going on also. Oh my lord. I'm gonna change up the color. Okay, let's put it this way. If you have a lot of industrialization, that means a lot of factories are running, a lot of refineries are running. That means fossil fuel usage also goes up. The byproduct of those, even though there's air pollutants and water pollutants, one thing that you need to have it in your mind is there are two heavy metals that goes up as a concentration inside of the natural water, groundwater, river, whatever the nearby area, and one of them will be lead in periodic table we call Pb. Don't ask me why, because I don't know why. Lead doesn't have any of a Le or those kind of thing acronym, if you will. It uses Pb, and also have mercury. Lots of people think, oh, does that start with M? No, it's not. You will learn it in grade 9 when it comes to periodic table. Mercury is Hg, which is one of the rare metal that stays at the liquid form at the room temperature. All right, let's talk about the water type. So, imagine you woke up in the morning, got thirsty, grab a clear glass, if you will, or any type of clear container, something that you can drink using it. Go to a kitchen sink, gather the water, and see what happened. I mean, let's admit, the one on the right side is an extreme example. You may see that some of the sediment float around and disappear though. It generally takes about, 5 seconds after you stop the water flow? The thing is, this fogginess that you see over here is an indication that in Alberta, we use tap water that has a high content of hard water. Hard water is not about, it's not a physical definition of soft to hard. Hard water is just another name that scientists bestow, especially to a situation that has high density, if you will, more dense water. Why is it more dense? It's because of the simple fact that it dissolved extra mineral. We call those hard water. An example that I can think of is, we talk about Lake Louise. What's the color of that lake, if you will? I mean, yes, there's a reflection of the light, all of the above, but let's put that aside. Lake Louise watercolor normally is like bright green / gray white color, isn't it? The reason that we see those unique color is because the water has a lot of calcium and carbonate in it. And calcium and carbonate, or calcium carbonate as a compounds together too, we call it limestone, or ingredient of chalk, basic chemical that you can find from eggshell, seashell. You got the idea. On the other hand, hard water doesn't have a lot of bubble. Soft water, the one that you see on the left side, and as you can see, bubbles are rising. This is an indication that your water do not have a lot of mineral in it, specifically calcium and magnesium. I forgot the exact chemical reaction reason for, but if you lack of calcium and magnesium inside of the water, you have bubble, and then the bubble stays on the top for a while. It's harmless bubble, and apparently there's something to do with smooth surface tension of the water. So an easy indication, mineral, rich water, hard water, have cloudiness going on, not much of bubble. Bubble disappear pretty fast, minimal to none. On the other hand, soft water, very clear, but lots of bubble that stays. And hard water especially have high concentration of calcium and magnesium. So if you think about minerals and salt that is being dissolved, yes, hard water has a lot. So that means in Alberta, we are basically drinking salty fresh water. Remember, salty doesn't mean table salt. So I'm not talking about saline water. But that's what Prairie's provinces experience. So I want you to look at the Canadians map over here. So we have BC, Alberta, Saskatchewan, yada, 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 all the way to the East Coast area. Now the thing is, if you look at the color scale, moderately hard, it's British Columbia area, slightly hard, more close to the East Coast, Ontario, Montreal, those kind of area. And if you think about Alberta and Saskatchewan, 14.4. I forgot. That's the how much grains per gallon, if you will. Very heavy, very dense. We called it very hard water. Some study actually suggests that is there any health risk? Well, apparently there's some condition called, well, this one I knew. There's some condition called varicose vein. If you don't know, those are like, how can I say, veins on your arm and leg seems like it's popping out. Some seniors have that condition due to their lack of elasticity on their skin. However, varicose vein happen because the flow rate of the blood, pooling of the blood is happening inside of a vein rather than the artery. And if you guys remember, artery has thick muscle layer, vein does not. It also has valve so that it prevents the backflow of the blood. Some studies suggest that if you drink a lot of hard water, then you will have a high chance of having varicose vein. The picture is a little bit disgusting, so I did not put it in here, but pretty sure you can search it up in Google. In some places in Ontario, water contains so much iron that it affects the taste. So regarding this, you need to understand that iron, which is chemical symbol of Fe. Funny thing about iron is it tastes like blood. Some people may say, Mr. Kim, why does it taste like blood? Did you taste metal, iron metal, and also you compare with blood? Well, the reason is because we have, I forgot how to, I think this is the best drawing I can do. Red blood cell, RBC, and at the center, we have something called hemoglobin. And hemoglobin has iron in it. Some people may say, Mr. Kim, if I have a lot of iron contents in the water, does that mean a good thing? It's actually not the best thing at all because iron rust. Iron actually react very fast and very, not a vigorous reaction, but it just have a short reaction time. That means it will somehow react with whatever the pipe of the that city or town that has iron-rich water. I'll show you a picture. Boom. So as you can see, look how nasty it is. There are a lot of buildup, isn't it? Which you can see in this picture over here. Why there's a buildup happening is because there are buildup that is happening because water is so hard. So what I mean by that is hard water. Let's say, what's a good example? Oh, I put it in the note over here. Smart Mr. Kim. Electric kettle, if you have been using electric kettle for a long time, you may notice that, well, water evaporate into gas form, or water, you just heat it up and you're gonna pour it to your, I don't know, mug for instant coffee, tea, whatever you like to. You may notice that there is a white buildup, and those white buildup, as those are solidified ion that has become a simple compound, like calcium with carbonate, those kind of thing. In this case, the one you see on the right side over here, sail buildup inside of the water pipe due to a long usage. You may notice that the surface area inside getting reduced, aka what water can pass through. That means water pressure, do you think it builds up or it drops down? In this case, it builds up, which is not a good thing because knowing that we are living in Canada, water pressure builds up. That means water stays in that area more too. If I don't use the water as a fast flowing water, then imagine it's a winter time. Water can freeze, and if water freezes, then the outcome is volume expand and pipe will crack. So in the previous slide, we talked about the surface area went down which means the volume inside get reduced too, if you think about three-dimensional way, which means pressure inside builds up. If you think about free water flow too, how can I put it in the sideway diagram? Imagine this is a cut diagram, good pipe, and the next one roughly similar, but you have some builds up. Like that. You may notice that in order to pass through this one, let's say I draw about 5 arrow to let water pass, and flow rate is whatever milliliter per second, if you will. That's a ratio unit, if you will. If you think about how much water that passed through this nasty pipe with the sail, then you will notice that it's definitely have less flow rate. So flow rate goes down, which means stresses build up more and more. And in fact, sediment also will build up more and more too. That's where I'm gonna end for today's class.